Welcome back to part 3 in this series of the new version 5 of the L12 amplifier. Well, you'll be delighted to know that we have finally come up with a solution which will make this amplifier stable and, dare I say, quite nice sounding. Our advice would still be, if you are not capable or don't want to modify these boards, don't buy them. Even if you buy the kit or the ready finished product as supplied, they are not very good. Choosing my words carefully there, but I'm sure you get the message. But if you're prepared to do really quite a small amount of modifications, you will get good results from them. I still would say that the board layout is very poor. Please be aware, for those, one or two people have commented about the design not being good and it's our fault. We have not designed this board. We purchased it as customers in the same way that you will. All we've done is to try and make it usable rather than e-waste, because without the modifications, that's exactly what it is, e-waste. Now, at the time of making this video, I have done minimal listening tests. I simply haven't had the time. So the only listening tests through a loudspeaker that I've done is here on the bench with my little Wharfdale monitors, and I wouldn't presume for 1 millisecond to suggest that is the way to auction these. But I have to say, my colleague in America, Ron, who incidentally will be speaking to you later, so you can look forward to that and finally put a voice. And if I can persuade him at some point, even come on the video directly and speak to you. But for the moment, you'll have to just put up with his dulcet tones, but he's going to tell you a little bit more about the product and the fact that he's spent a number of hours listening to these with headphones. Whilst it's not specifically a headphone amplifier, clearly you can use it with headphones. That's a way of interrogating the product rather than relying on loudspeakers and the acoustics. Anyway, he will speak to you more about this later. So let's get down to business. First of all, I'm going to show you what you need to do to get this to be a good working product. Later in the video, I'm going to show you how to set up the quiescent current, because again, out of the box, it's a bit unstable and draws too much current, but I'll go into that a bit later on. And then I'll just show you what it looks like with a square wave and sine wave, but it's not a full test at this stage. If you've watched part 1 and part 2, which if you haven't, please do so, because then you'll know what I'm talking about. Always good to know what I'm talking about. I know it's quite heavy going, but if you've got these things, you don't want to make a mistake, because if you put the wrong component in the right place or the right place in the wrong component, I don't want to be responsible for it going bang. So please study these last 2 videos all the way through. But these mods are easy, honestly. So let's get into the first mods. This is the latest up-to-date circuit. There was a minor error on the previous circuit, but it was purely the way it was written. Just literally got 2 components, both resistors, in the wrong position, but it would make no difference to the working of it. It's purely cosmetic. I'm also going to include some photographs of the board layout, and so you can easily identify the components. The first thing to modify is Q10 and Q9. This may seem a strange thing to do because I've basically shorted out or linked together the collector and the emitter. Now, if you simply remove that transistor completely, for some reason or other, the board is still unstable. So neither of us are completely sure why it has to be done like this. Whether it's a function of board layout, to be perfectly honest, we don't know. You can just literally on the underside of the board blob the two components legs together, and that's all you need to do on that particular mod. The second mod is to add two capacitors. They're both 1 microfarad and not electrolytic. They can either be ceramic or any of the other types of better quality capacitors. But please make sure if you choose ceramic that the voltage rating is adequate, because this does have the full supply. So look for something like 64 volts or more, but the only problem is they'll become quite big, of course. They're 1 microfarad, C13 and C12 as shown here. And they're basically bypassing the 100 microfarad, which is C5 and C8. It looks like they're separate on the circuit, but in reality you're putting that capacitor directly across those 100 microfarad. And again, they will go underneath the board and they out of sight basically, and there's plenty of clearance that you'll be able to do that easily. The next couple of mods are 2 changes of resistor. Not strictly to do with stability, but yes it is anyway. These deal with the quiescent current, which out of the box is way too high, and the resistors in question are resistor 26 and 21 as shown here. They were originally as fitted 33 ohms, and you need to replace that with 100 ohm resistors. If you haven't built these boards yet, I would suggest you actually put these 2 resistors on the back of the board rather than on the top of the board, simply because of ease of access. And should you decide to mess with this yourself and change some of the voltages and currents, it's easier to do it if this resistor is mounted on the back of the board. If you've mounted it already, or you've purchased the pre-built ones, it's quite hard to remove those 2 resistors if you can remove them easily. But I would still suggest you would put the replacement 100 ohm resistors on the back of the board. If you find you can't unsolder those 2 resistors very easily, sounds brutal, but I get a pair of long nose pliers and twist them and remove them like that. It does a neat job, and you can just tack those 2 resistors on the back. But how you do it, I will leave to you, because I don't know the tools you're using, your skill or whatever. But that's what you need to do. How you do it is up to you. The other mod that's fairly important, which unfortunately won't fit on the board, is the loudspeaker Zobel network. The L12 has never included this on previous models, and whether to be quite honest, this doesn't have any direct reflection on the current problem, because the instability is actually internally generated, whereas the reason for using a Zobel network is to interact better with the reactive load of a loudspeaker, i.e. inductance, capacitance, and a bit of resistance thrown in as well. Most amplifiers will incorporate a Zobel network, and it's a very simple device. It uses an inductor, one of these. This is one I made earlier, and it uses a resistor in parallel with it. I'll bring up on the screen presently the actual construction of this coil, but it's relatively uncritical. This particular one that I have here is one I've removed from a Yamaha amplifier, ironically, and if you don't have access to this, I'll give you the details of how you can make one, but they are relatively uncritical, so don't think it's a precision piece of kit. The resistor inside should be about a 2-watt rating, and any type, again, relatively uncritical. These particular ones that I have here are 4.7 ohms because I simply have them, but anything between 3 or 4 ohms and 10 ohms will be fine, and you can either place it in the coil, well, preferably just one, like that, and join the leads so that they are effectively in parallel, or you can put them like this, where it's literally just soldered underneath, whether you can see that properly. But it's a very simple thing, and often the best place to hang them is on the output sockets of the amplifier. That will aid stability with an inductive load, but isn't directly a cure for the instability of the amplifier. It does help, but this is something you should do anyway. One modification that you can make, which has nothing to do with the stability, but is something that you might like to consider. Out of the box, the gain of this amplifier is really quite high, and you could argue it's fine if you don't want to use a preamp, but if you want to use anything that's fairly high output or a preamp, whatever you do, of course, don't stick a volume pot on the input. Don't want to do that. If you want to lower the gain, that can be done quite simply by changing resistor 18. Out of the box, it has a 330 ohm resistor, and you'll see by the little table in this slide, you can reduce the gain anywhere in between those, but those are fixed levels that we've tried and tested. Ron in particular uses a preamp, as indeed I do, and so it's better to have lower gain on the amplifier. Two advantages, small but advantages. One of them, it will lower the noise floor, which is already pretty good, but it will, because you're getting more negative feedback basically. More negative feedback means lower noise and lower distortion. And we hope to have some distortion figures for you in a follow-up video to this follow-up video. But at the moment, we just wanted to get the video out so that those of you that have got them sitting in a box waiting for somebody to come up with an answer, this is it.
Hello, my name is Ron. Mike and I have been working on these boards for a little while now, and we think we've come up with a solution. Thought you might like to hear my impressions of how it sounds. Bass and clarity, very good. Mid-range is good. The highs and details are good. But that's only after the modifications that we have made. Without them, this board's not very good. In the background, Mike may be showing you a picture of my test setup where I was listening with headphones. I listened for a couple of hours. Sounds very good. I'm quite happy with them, but again, only with the modifications. It is only necessary to make the minimum level of modifications, which Mike will describe to you and which is shown in the schematic minimum mods and with the highlights. I would also advise that you should reduce the gain of this board at very high gains, 31x as they were shipped. It's a bit much, and so I choose to reduce it to 11 times for my applications. However, I have provided details for both 11 times, 21 times roughly, and of course the 31 times original. Actually, with modifications, these are good. But in their original form, it's a solid do not buy, unless of course you're willing to make the mods. It is worth mentioning that the FET, or alleged FET, on the board isn't really a FET at all. It tests very solidly as a bipolar device. When you buy the bare board, as I did, you can test it independently of other connections, at least one half of it, and there is absolutely no question it's an NPN transistor. So this is an NPN transistor array, not a JFET array. Thank you very much.
This is how you test for DC offset. One leg of your probe, that's the speaker output, and the other one goes to ground, which is this one. Set your meter to millivolts DC, between 9 and 10 millivolts of offset. For measuring the quiescent current, this is the pot. There's only one, you can't get it wrong, and you turn it completely anti-clockwise. This is where you measure. You'll see on the board there's a little mark test. You put your positive probe into there, and this is the speaker output, and you put your negative there. Now they do mention in the propaganda that you should set this to 3 millivolts, which is 30 milliamps of current. Since we've been doing tests on this, we've found that it's a little on the low side, to be perfectly honest. It depends on what you regard as low, but I would suggest, or we would suggest, that you aim for about 4 millivolts, i.e. 40 milliamps. And the reason for that is crossover distortion. Now, again, it can be argued in the audio passband, 30 milliamps is fine, but if you wind the frequency up to about 30 kilohertz, you can see a crossover spike at very low levels at 1 or 2 watts output. And so if you believe that you can't hear that, make it 30 milliamps. For the sake of 10 milliamps, crank it up to it. It will be rock stable, I promise you. You won't get thermal runaway or anything horrible will happen. So that is our advice. That removes that tiny crossover spike that you get at extreme frequencies and extreme low powers. You must leave it like that for, I would suggest, providing there's no problems, monitor the current, and it should stabilize pretty well where you left it at a very low level. After about 15 minutes, turn up the pot until you get 4 millivolts, which will give you 40 milliamps. Now, I assume that most people must realize, or hopefully, this must be connected to an adequate heatsink. If you don't, you will blow up the power transistors. Guaranteed. And the bigger the heatsink, you've seen the size of heatsink I've got on here. For music, they're a little over the top. But if you're going to run it into 4 ohms at high powers, certainly if you're going to be testing it on sine waves, you need a big heatsink. You really do. It's a powerful amp. So that's the thing to do. Set it for that and then leave it for another 10-15 minutes, and it'll drift around a bit. They always do. And providing it stays around that level, little bit up, little bit down, it will be variable by the temperature of the room. And then you can connect preferably a load, but if you haven't got a load, a loudspeaker, because all should be well at this stage. Give it a bit of stick. If you've got sine waves, put some of those in. If you've only got music and a loudspeaker, play it loud. It should very quickly, or certainly within 5 or 6 minutes, the quiescent current should drop back to about the 40 milliamp scale. Ironically, it isn't dependent on the heat sink of the power transistors, because there's no sensor there. And because of the way it's designed, unlike some circuits, you cannot get thermal runaway on this, because the temperature on those sensor transistors works in a negative way, a bit like FETs. You have no danger of thermal runaway. It will always come down, but there'll always be a lag in time. Here is our 1 kilohertz sine wave, and I'll increase the amplitude now until we hear, well, you might actually hear it, clipping. And at the moment I'm running with 46 volts of supply, so a little below there's clipping, and that is 30 volts, as you can see here, times 10. So that's, I think that works out to about 105 watts. Here we have a 1 kilohertz square wave, and you can see if you compare it with the original, there's the usual digital mush from a digital scope, but there's no instability there at all. It's pretty stable. There's not a hint of any problems, instability there, and not a bad looking square wave either. Do you like my t-shirts? I'm going to be walking about in the street looking like this. But there will be a follow-up video showing how to connect it for those that don't know, and some recommended products to use. Speaker protection board. You must use a speaker protection board. The best amplifier on the planet can go wrong, and if it puts 50 volts or even 100 volts on your loudspeakers, they won't like it, and nor will you. Thank you for watching. Much appreciated.